Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize patterns in geometric figures as being functions. How are we learning it? Through the Recognizing Patterns as Functions Part 3 notes and the Recognizing Patterns as Function Part 3 assignment. When can we use this information? To recognize repeated patterns in daily tasks and their common solutions. How do you know you learned it? By getting a score of 4 on the Recognizing Patterns as Functions Part 3 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the Recognizing Patterns as Functions Part 3 notes, and then I'll give you time to complete the Recognizing Patterns as Functions Part 3 assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Representations of Function study guide and any incomplete assignments that you may have. Let's take a look now at the Recognizing Patterns as Functions Part 3 notes. The notes begin with the learning goals and success criteria. Now, what is a function? A function is a relation in which each element of the domain is paired with exactly one element of the range. So that means that for every x, there's exactly one y that matches with that x value. If there is more than one y to match up with an x, then it is not a function. So let's look at some examples here. So we have a bunch of dots here. We have tables, we have equations. We can see it in various different ways. But if we notice here, there's an x value here at x equals negative 4. And y is negative 3. There's no other y value that matches with it. Same thing with all of these. Here we have a straight line. I can pick any x value, and there's only one y that matches it. Here, again, same thing. Now, non-functions look something like this. So notice, if I pick an x value like x equals 0, so when x is 0, y is this one, it's this one, and it's this one. So there's 3 different y values that match up. That doesn't work. Same thing here. If we look here at this x value right here, there's 2 values there for y that make it true. So that doesn't work. Same thing here. If I pick x equals 0 here and here, there is 2 points. So again, not a function. Now, what is a function value? A function value is the resulting range value, so the y value, after a given domain value is selected that makes the function true. So in order to find a function value, we're going to plug in the given value for x. So whatever they tell us they want for x, the function value is the result or the output. So for instance, if I have f of 3 is equal to x minus 5. So all that means is I'm going to take 3 and plug it in, and then the result is what we call the function value. So we plug 3 in for x, and we get 3 minus 5, which is negative 2. So negative 2 is my function value. So finding a function value from a graph. So which of the following letters represents f of 4? So I'm going to go here to where x is 4, which is here. So notice I have f of 4 is represented by this dotted line p here. So it's right there. And we would say then that p represents f of 4. Now if it asks for the actual solution, then that would be c. So P is our answer in this one. Now, if it actually gives us the value, so 2, f of 2. So here we would say f of 2, which is right here, and x is actually 2. So that means that we're going to select the actual point on the graph, which in this case is D. So if you see something like this in coordinate form, you're going to find the actual point on the graph. If you see it and it's just this part, like f of 2, it's going to be the value on the dotted line, which would have been b. Now, how do we find a function value from an actual equation? So it says, what is the function value for f of 6 for the function f of x is equal to 2x minus 5? So what we're going to do is we're going to take f of x equals 2 minus 5, and we're going to plug 6 in for x. So it goes here and here. So f of 6 is equal to 2 times 6 minus 5. Well, 2 times 6 is 12. 12 minus 5 is 7. So the function value for f of 6 is 7. Now, how do we perform operations on function values? So let's say, given the table above, what is f of 2 minus g of 1? So what that means is we're going to find what f of 2 is and then subtract g of 1 from it. So f of 2, if we look at f of 2, we can see that the value here is negative 2. So when x is 2, y is negative 2. So we keep that there. And then we look at g. So g of 1, which is here, when g is 1, the g of x is negative 1/2. So we take those two values, and then we're just going to subtract them, just like it says. So f of 2 minus g of 1 is the same thing as negative 2 minus negative 0.5, which is really plus positive 0.5. And we get negative 1.5 as our solution. Let's look at another example. So this one says, what is 4 times h of negative 2? So if we take h, so when h is negative 2, y is 4. So there's our value. And then we want 4 times that. So 4h of negative 2 is the same thing as 4 times 4. And 4 times 4 is 16. Now let's look at another example. So it says, what is f plus g of 2? Well, when we write that out, f plus g of 2 is the same thing as f of 2 plus g of 2. So when we do that, we find f of 2, which is negative 2, and g of 2, which is 1. And then we're just going to add those two together. So we add up negative 2 plus 1, which is negative 1. So when we do this and you see f plus g or f minus g or anything like that, really what that's saying is we're going to take f of this value and then whatever operation's there and then g of that number. So let's see another example of this. This time we have fg of 8. Well, fg just means multiplication, so really we can break that up and it becomes f of 8 times g of 8. So f of 8 in this case is 40, and g of 8 is right here, which is 4. So now we just multiply these together and we get 40 times 4, which is 160. Now let's take a look at an example here. So we have a pattern here where each time it's increasing. So we started with this shape here, and then we added basically a row here, and then we added another row. And so each time we're adding a row of these. So each time we add a row, we're really adding 3 blocks. So what patterns can we recognize about the figure? Well, in figure 1, there's 5 squares here. In figure 2, if we count them, there's 8. And in figure 3, there are 11 squares. So using what we know from our figures, is there a way to determine how many squares will be in any given number of figures? So let's say we want to know how many squares will be in figure 15 or 20. Is there a way to do that? Well, when we do this, you should be able to see that we have our original row here. So it's 3 times the number of rows because we add a row each time. So 3 times n, number of rows. And then we have these 2 on the ends. So it would be plus 2. So in this case, our function could be 3n plus 2. Let's look at another example. On this one, we're given a tile, and each of them is broken up as well. So we have these patterns inside here. And notice there's a quarter piece here, a half piece here, and so on. So in figure 1, there's one half tile, meaning it cuts up into part of it. In figure 2, there's 1, 2, 3, 4, 5 half tiles. And then in figure 3, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 half tiles. So the question is, can we write an equation to figure out the pattern for this one? So what we should notice is from figure 1 to figure 2, we added 4 tiles to our figures. And then here from 5 to 13, we added 8 tiles. So we can see that the pattern is it's going to be 4, 8, then 12, 16, and so on. So each time we're going to multiply 4 times whatever the previous figure was, which is n minus 1. So it'd be 4 times n minus 1 would be my pattern. Now on this one, you can see that we have some hexagons. So here in the first one, we have 1, 2, 3, 4, 5, 6 sides. Then when we add 1 to it, we now have 11 sides because this one is shared. Then we do it again, and we have 16 sides. So what's the pattern we recognize here? Well, each time we're adding by 1 less than our original sides. So we should be adding by 5 each time, right? Because 6 plus 5 is 11. 11 plus 5 is 16. So it's 5 times n minus 1 times however many we had before plus the original 6. So we have 5 times n minus 1 plus 6 would be our equation. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click Start the Activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the Recognizing Patterns as Functions Part 3 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take you to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll go ahead and click Next. And we're given a pattern here with these different sticks that are put together to form these shapes. It says, what is the function for t of n, meaning the number of toothpicks? So you're going to go ahead and put a function in there. Then we'll click Next. Then we're going to do it with blocks. And you'll put the functions for those. And then same thing here. We have a function for this one. So the perimeter of this figure, this one, and this one. And then we have it also for the number of gray squares and white squares. Now, to help you with this, I have provided you with the answer key. So if you go here and it says slide to answer key, if I go to zoom in so I can see this a little better, I can see that this is the answer for the function. Now, what I want you to do, though, is I want you to enter this answer into your Desmos activity, and then I want you to discuss among your table groups where this answer came from and how do you know it's correct. And you'll do the same thing for the other 2 slides. And then when you're done with that, you'll go ahead and go back to your Google form and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.